Hello, welcome back. So now in this we will solve an example to understand how we can find out moment of inertia of a composite area. So here we have to find out moment of inertia of the area shown in the figure about x-axis. Now the figure is this one. So you can see here that there is a rectangle and the rectangle is having a hole, a circular hole. So this hatched part is area, a solid area, and this is a hole. So in this case, now our first step will be to find out the common area. So in this case, you can see we have first common area as this rectangle, and the second common area is this as circle. So So we will be finding moment of inertia of this rectangle and this circle, and to find out moment of inertia of the whole rectangle, what we will be doing is I will first find out moment of inertia of the rectangle about the x-axis, and also I will find out moment of inertia of this circle about the x-axis, and I will deduct the moment of inertia of circle circle 2 of circle from the moment of inertia of rectangle. So how we do that we will see now. So you can see I have divided this area, this composite area, into two area. One is a complete rectangle and the second one is a solid circle. So but they should be at their own position. So we have to find out moment of inertia about x-axis. So you can see this x-axis is not passing through the centroid of circle and rectangle. So therefore, there is a distance between them. So what we have to do is we have to apply parallel axis theorem in this case. So first we will take the case of circle. So finding the moment of inertia of circle, we will use the parallel axis theorem, and the formula for parallel axis theorem will be like if we have to find out moment of inertia about x-axis for a circle, it will be I bar, which means moment of inertia of the circle about its centroid, this one, about, because this you can see this x-axis is will be having a parallel axis of this circle passing through its centroid. So distance will be 75 mm, and the area of this circle will be pi r square, and so this will be a dy square. So this is our formula for parallel axis theorem. So I bar x is the centroidal axis. I mean moment of inertia about the centroidal axis parallel to the axis about which we have to find out moment of inertia. So as I have shown you in the previous part, the moment of inertia of some common area. So we know that moment of inertia of the circle about its centroidal axis will be pi by 4 r to the power 4. So that is the value of ix bar, plus area will be pi r square, and dy is this one, this is the dy, and the value is already here 75 square. So putting all the value, we get the value of moment of inertia for the circle. So it is already provided here. So this is how we write, and solving it, we get the moment of inertia as 11.4 into 10 raised to power 6 mm to the power 4. So this is the moment of inertia of circle. Now we will find out moment of inertia of the rectangle about the base. And as you can see in example 1, I have calculated moment of inertia of rectangle about its base, which was bh cube, by 3. So we can use that value here also. So now moment of inertia of rectangle, and as you can see moment of inertia of rectangle about x-axis can also be calculated by using the parallel axis theorem, and this will actually yield bh cube by 3. it will be 3. So either we directly put value or we put value like this: moment of inertia parallel to this axis, which is say x dash s axis. So this becomes bh by 12 plus area becomes b into h, and dy square. So putting all the value here, bh cube by 12. So putting all the value here, we get the value as 112.5 into 10 raised to power 6 mm to the power 4. So this is the moment of inertia of the whole rectangle, and this is the moment of inertia of whole circle. But here in our problem, the circle is hollow. This is basically a hollow. So to find out moment of inertia of this composite area, we have to deduct moment of inertia of the circle from the moment of inertia of the whole rectangle, and then the answer will be the moment of inertia of this composite area. So this is what we are going to do. Ixx minus, so this will be the moment of inertia of circle plus moment of inertia of rectangle. So this minus sign shows that it is a hole. So the answer will be 101 into 10 raised to power 6 mm to the power 4. So that is the problem example 3. So in the next part, we will take another example to understand the concept more. Thank you.